This video is for your Chapter 9 study guide. So your Chapter 9 test is going to be about tests of significance. So the first thing I want to talk about is what is a test of significance. So that's going to show whether an outcome happens from chance or by using a null hypothesis and an alternative hypothesis. Your null hypothesis you're going to write is H sub 0 or H naught, and your alternative hypothesis is H sub A. Now, you can always write your null hypothesis as being either x bar or mu equal to, and your alternative hypothesis is either going to be not equal to or less than or greater than. Part of your significance test is going to involve what we call alpha. So alpha is going to be your significance level. So this is going to be the probability of rejecting the null hypothesis when the null is true. Now when you read that, some of you may recognize that as being a type 1 error. If you do not recognize that as being a type 1 error, don't worry, we're going to talk about it later in the video. But what you're finding whenever, or what you're doing is you're testing whether or not you are rejecting the null hypothesis when the null is true at a specific value. So this is going to correspond with a confidence interval or confidence level that we saw back in Chapter 8. So the way that we represent alpha is going to look like a fish. So it's the Greek alphabet letter alpha. And so if it corresponds with a specific confidence, if an alpha is equal to 0.05, this means it's going to correspond with a 95% confidence level. So we have to, it's also important that we know that this alpha is a predetermined value. So sometimes it will show up in your problem, and they'll tell you at a specific significance level. But if they do not give you an alpha for some reason, always use 0.05. So 0.05 is what you're going to use if they don't tell you what your significance level is. Now, you're going to use this alpha in conjunction with what we call a p-value. So your p-value is going to be the probability of finding the observed or the claimed, or more extreme than the observed or the claimed. So you're going to use the p-value and this predetermined alpha that we talked about up here, which is your significance level, to either reject or fail to reject the null hypothesis. So remember, the null hypothesis is going to be a particular claim. The alternative hypothesis is basically the opposite of that claim. And using your p-value and your alpha, you're going to decide if you should go with the null hypothesis or the alternative hypothesis. However, sometimes it won't be as easy as just comparing those two things. Sometimes you won't be given your p-value, and so you may need to do a 1-prop z test. Now, you could calculate that p-value by hand, but if you don't remember how to do that, you can always use the calculator. The only problem with that is if you use the calculator on an FRQ, you need to make sure that you call it out and say, I'm using a 1-prop z test. That's the only way that they'll give you credit for finding the p-value if you do it on the calculator and there's no work that goes along with that. Now, the whole thing about significance levels or significance tests is you are trying to decide if you are going to reject or fail to reject the null hypothesis. And so one way that we talked about in class that's easy for you to remember which one you need to go with are some wise words from Snoop Dogg. So Snoop says, if the P is low, the hoe must go. What you're going to do is you're going to compare your p-value and this predetermined alpha. So what Snoop Dogg is saying is if your p-value is less than your alpha, then that means that you're going to reject the null hypothesis. If your p-value was greater than your alpha, then you're going to go with the alternative hypothesis. Now, I was very specific to say that I'm not going to accept the null hypothesis or I'm not going to accept the alternative hypothesis, because you can never accept the null hypothesis or the alternative hypothesis. You can never say that those are definitely absolutely true. You just say that there's evidence that supports the null hypothesis or there's evidence that supports the alternative hypothesis. Other important things that we're going to talk about is the power. So the power is the probability of rejecting the null hypothesis when the null hypothesis is false. So this would be saying that we are going to go with the alternative hypothesis, and that's a good call because our null hypothesis is something that is not true. So the power increases as n increases. And the reason that the power increases as n increases is because n is our population. So because a larger sample size provides more information about the population, then our power is going to increase as n increases. So whenever you do these significance tests, there are two types of errors that could show up. The first is a type 1 error. And so a type 1 error would be like a false positive. So this is rejecting the null hypothesis when you shouldn't have. And so you may remember from when we talked earlier in the video that a type 1 error is a false positive, rejecting the null hypothesis when you shouldn't have. That is what alpha is. So alpha is the probability that this happens. Alpha shows that you reject the null hypothesis when you shouldn't have, and how often or how likely that is to happen. A type 2 error is going to be a false negative. So a false negative would be failing to reject the null hypothesis when you should have rejected the null hypothesis. So now let's get into the problems that are on your study guide. So the first one says, eHealth Insurance claims that in 2011, the average monthly premium paid for individual health coverage was $183. Suppose you were suspicious that the average or the mean cost is actually higher. So state the null hypothesis and the alternative hypothesis you use to test this. All right, so if we want to state the null hypothesis and the alternative hypothesis, we're going to start with the null hypothesis. And we're going to use the information that they gave us in our problem. The claim is that the average monthly premium was $183. So we're going to say mu is equal to 183. The alternative hypothesis is going to come from the fact that you are suspicious that the average cost or the mean cost is actually higher. So if it's actually higher, then that would mean you were saying that it was greater than the claim of 183. So your alternative hypothesis is going to say that mu is greater than 183. Now it's also important that you state what the mu represents in this problem. So in this case, the mu is going to be the average monthly premium. Number 2 says, given an experiment where the null hypothesis shows that mu is equal to 12 versus the alternative hypothesis where mu is greater than 12 and a possible correct value, it gives you the definition for a correct value there, the value obtained for a unit that is without error of 13, what increases as n increases? So remember from the important information at the beginning, as n increases, the power increases. And if you'll remember back to this important information over here, the power is the probability of rejecting the null hypothesis when the null hypothesis is false. If n is greater, then the larger the sample size is going to give us more information about the population. Number 3 kind of goes along with that same thought. So consider a hypothesis test where the null hypothesis shows that mu is equal to 110 and the alternative hypothesis shows that mu is less than 110. Which of the following choices of significance level and sample size result in the greatest power of the test when mu is equal to 105? So really a lot of that information in there is not important except for the fact that you are looking for the greatest power. And so if you're looking for the greatest power, you would be looking for A when n was equal to 50, 50 because it's bigger than 15. So for this one, our answer is A. Number 4 says a consulting statistician reported the results from a learning experiment to a psychologist. The report stated that on one particular phase of the experiment, a statistical test result yielded a p-value of 0.24. Based on this p-value, which of the following conclusions should the psychologist make? So A says the test was statistically significant because a p-value of 0.24 is larger than the significance level of 0.05. So as you look at the answer choices, you'll notice that the word statistically significant show up in every single one of the answer choices. So it's important that we talk about what statistically significant means. So statistically significant is going to have to do with the p-value. In order for a test to be statistically significant, you want a p-value of something that is less than 0.05. And 0.05 in this case because we're not given an alpha. So on the first one, it says the test was statistically significant because a p-value of 0.24 is larger than a significance level of 0.05. That's incorrect. That's quite the opposite of what we want. So we want a p-value that is smaller than 0.05 for it to be statistically significant. The test was statistically significant because p equals 1 minus 0.24 equals 0.76, and this is greater than a significance level of 0.05, so that's incorrect. The test was not statistically significant because 2 times 0.24 is equal to 0.48, and that is less than 0.5, and that is not true. D says the test was not statistically significant because if the null hypothesis is true, one could expect to get a statistic at least as extreme as that observed 24% of the time. Remember that your p-value is going to, if you go back to the beginning that we talked about here, your p-value is the probability of finding the observed or more extreme. And so for this particular one, it's saying that if your p-value is 0.24, then you are expecting to get that claim at least as extreme as that 24% of the time. So this answer is actually going to be correct. And again, that's because of the definition for a p-value. P-value being the fact that it is the probability of finding the observed or more extreme. And so whatever your p-value is equal to, that is that probability. Number 5 says pregnant ladies take a glucose tolerance screening during the 24th week of pregnancy to detect developing gestational diabetes. This condition can lead to premature labor. Describe a type 1 and a type 2 error and the consequences for each error type. So for a type 1, remember a type 1 is a false positive. So this would mean that the pregnant lady is diagnosed but doesn't have it. And so this lady receives medication but doesn't need it. Type 2 error is going to be a false negative. And so pregnant lady is not diagnosed and has the potential for gestational diabetes And so this person is going to not receive needed medication. And of course, looking at these two types of errors, type 2 is obviously going to be the one that is the most harmful. Number 6 says we want to test a null hypothesis equal, or where mu is equal to 1.5 versus an alternative hypothesis where mu does not equal 1.5 at a significance level of alpha equals 0.05. Below are 95% confidence intervals for mu calculated from a random sample. Based on each finding, make a decision. So if they give you the confidence interval, what you're basically looking for is my claim inside that confidence interval? So on A, if I'm looking at 1.4 to 3.6, 1.5 would be in between that lower bound of 1.4 and that upper bound of 3.6. So because our claim is inside that confidence interval, then we would need to fail to reject the null hypothesis. And again, that's because our claim is inside the confidence interval. 3.6 to 5.3, 1.5 is not inside that confidence interval, so for this one we're going to reject the null hypothesis. 1.4 to 1 to 1.4, for that one we're also going to reject the null hypothesis. And 1.3 to 1.6, because 1.5 is inside that interval, we're going to fail to reject. The null hypothesis. And the last one says a test of the null hypothesis where mu is equal to 60 versus the alternative hypothesis where mu does not equal 60 produces a sample mean of x bar equal to 58 and a p-value of 0.04. At a significance level of 0.05, what can be concluded? So if we think about our p-value is 0.04, and that would be less than our alpha, which is 0.05. So because our p is low, we must reject the null hypothesis. So what that means is, you might say something like this: because our p-value is less than alpha, we must reject the null hypothesis. So what that's saying is there is sufficient evidence to conclude that the alternative hypothesis, which is mu does not equal 60,